So welcome everybody to this latest A2 video on 162 Maths, and in this video we'll be continuing with statistics with a focus on hypothesis testing, where we are comparing correlation coefficients. Now we'll put a copy of the notes and the examples with their solutions in the description below for you to have a look, to copy and print and keep for your file. So let's get started. Now in terms of significance test for correlation coefficients, so when a correlation coefficient has been calculated, it is usual to make an assessment of the degree of correlation. So for example, if there is strong or weak correlation, so very similar to what you would have done at a scatter diagram. Now there is a significance test that allows you to decide whether there is correlation between two variables backed by statistical theory rather than suspicion. So rather than you simply looking at a scatter diagram and deciding whether it's got positive or negative gradient, or whether it's weak or strong, or even no correlation, there is an actual calculation that allows us to do this, and this is what we call PMCC, which stands for product moment correlation. Now this gives us an R value where we can measure correlation as a value between -1 and 1, -1 being strong negative correlation, 0 being no correlation, and 1 representing strong positive correlation. How we generally sort of represent this in terms of mathematically is by having that R is between -1 and 1. So in terms of when R is close to either -1, 0 or 1, it's very simple to state a conclusion that a relationship exists between two variables. However, what makes it strong or weak? Now to decide this, what we can do is use a significance test. Now in order to carry out a significance test, we need to assume that the variables are normally distributed with a correlation coefficient of rho. Now rho, it looks like a P, and let me just go through what it actually looks like. So it's a bit like a 0 with a straight line going down, and how we pronounce that is rho, which is a Greek letter. And this is different to probability, and that's really important. I don't know who's decided on using this Greek symbol to represent this. But obviously when you ever see a P, particularly in statistics and maths, you're automatically going to think probability, and this has got nothing related to probability. It is simply just a symbol which we call as rho, which heavily resembles a P. And this is referred to as the population correlation coefficient. Now in terms of the null hypothesis, so this falls in line with the hypothesis testing you would have done at AS with binomial distribution. So the null hypothesis, which you represent as HO, the null hypothesis, always the correlation coefficient is 0, so i.e. that there is no correlation between the two variables, and that's always going to be fixed. So the null hypothesis will always be that there is no correlation between the two variables, and this can be written as HO is where rho equals 0. Now the alternate hypothesis, H1, depends on whether the test is either one or two-tail test. Now if it's a one-tail test, now if you think there is positive correlation between the two variables, then your alternate hypothesis will be where H1 is where rho is greater than 0, because obviously you're expecting some positive correlation. Now if you believe that there is negative correlation between the two variables, then your alternate hypothesis for a one-tail test will be where rho is less than 0. Now if you are looking at a two-tail test, then you are looking for, well, you're basically just looking for correlation, but you're not specifying whether it's positive or negative. All you know is that the two variables have got some form of connection, and this is where rho is going to be not equal to 0. Now the calculated value of R, which is the PMCC, is compared to the critical value, both of which will be given to you in the question. Now it is possible for you to work this out, but with the AQA scheme of work and the syllabus, is that all you need to be able to do is recognize the number. You don't need to worry about how it's calculated or to actually calculate it. Those two general values of the critical values, which is rho, and the PMCC, which is R, the correlation values, will be given to you explicitly in the question. Now your calculator does give you that R value, so if you've been taught it, brilliant, great, well done. However, for this particular course, you're not going to need to know how it's calculated or anything to do with that. It's just a case of just analysing it. Now if the PMCC, which is the correlation of R value, is further away from 0 than the critical value, then you have sufficient evidence to reject the null hypothesis and decide that rho is not equal to 0. Now instead of using the critical value, you can also compare the rho value for PMCC, which is our R value, to the significance level. And again, the significance level is like your margin of error, so very, very similar concept to what we've done in hypothesis testing with binomial. Now you can accept the null hypothesis if the rho value is greater than the significance level. Now in terms of the general steps, now this is really important because usually hypothesis testing with correlation coefficients doesn't really carry that many marks. It usually carries 4 marks. Some of them is just 2 marks are basically generated from setting the parameters, and then the other 2 marks are you drawing your conclusions with a bit of evidence. Now in terms of the step 1, just like with hypothesis testing with binomial, your first step should be to always state your null and alternate hypothesis using the correct notation. Now your second step is to state the type of the test, whether you think it's a 1 or a 2-tailed test, and also state the significance level. Now again, the significance level is an absolute joke of a mark simply because it's always given to you in the question. This is something that you're never going to need to know. If you are given that bit of a freedom, then you can choose what your significance level is, but the problem is that when you give students the opportunity to choose their significant level, you're going to have so many different answers, it's going to be near impossible to mark off on the whim. So, and the third step is that you state your acceptance and rejection reach criteria. So this is where you're either comparing it to the critical values or the significance level. And then you state your conclusion. Now again, whenever you're stating your conclusion in maths or in particularly in stats, you always want to give a mathematical statement, which is basically using mathematical reasoning and words and vocabulary, the mathematical evidence, which is where you're using your calculations or inequalities, and then basically sum it all up with the real life meaning. Now the real life meaning might be it's reiterating the math statement, but you just want to kind of put it in context of the question of what it actually means. Now in terms of additional notes for step 3, you're going to have a choice. You're either going to do one of 2 things when you are analysing to decide whether you're accepting or rejecting the null hypothesis. So you're either going to compare a given PMCC, which is an R value, to the critical value, or you're going to compare the rho value to the significance level. And again, that is all going to be given to you. It's just a case of picking and choosing which one you need to use. Now in terms of the general conclusion, let me just zoom out a little bit so you can actually have this. Now this is basically where step 4 comes in. Now, as I've mentioned, you're either going to be using one of 2 comparison models based on the information that has been given to you in the question. So in example 1, where you're given an R value and a critical value, is basically if your R value is close to 0, then you accept the null hypothesis. If the critical value is close to 0, you accept the alternate hypothesis. Now remember that the wording is going to be a little bit different, so R might be replaced with test statistic, but they both mean the same thing. Now in terms of the second method you can use, so you can compare the rho value with the significance level. So if the rho value is greater than significance level, then you accept HO. If the rho value is less than the significance level, you accept the alternate hypothesis. And this is definitely something that I would be revising in this particular topic. So let me just put a little bubble around this to make sense of it. Now as I said, a lot of this hypothesis testing with correlation coefficients is basically just remembering the steps and the methods. There's no formal calculation you need to do. It's all about analysing and comparing 2 values, picking out those 2 values from a big waffle of a bit of information, and then drawing a conclusion from it. So let's have a look at some examples to try and make sense of what I've just said. So in this question it says that average annual temperature and rainfall in 11 UK towns are measured to investigate whether there is any correlation between the 2. Now the hypothesis HO, or the null hypothesis, has got a rho value of equals 0 and H1, where rho is not equal to 0, are being considered at a 5% significance level. The test statistic for the sample is 0.6137, which has a rho value of 0.0446 for a 2-tailed test. It says state with reason whether HO is accepted or rejected. Now in this particular question we're given a lot of information, and we're actually given a fair bit of information that actually quantifies a few couple marks. So whenever you're starting these questions, let me just go through what those 4 steps are. So let me just split this page in half and let's have a look at solution. So in terms of the very first thing, what you want to do is state what the alternate and the null hypothesis is. Now again, this is given to us in the question where rho is equal to 0 and h1 is where rho is not equal to 0. And we're obviously looking at a two-tail test. And we're looking at a 5% significance level. Now the next thing we then need to do is compare the coefficients. So in terms of this, we know that our test statistic is equal to 0.6137, and I know that my rho value is equal to 0.0446. Now in terms of comparing, so this is where I need to then use that little comparison sort of brief. Then what I've got is that as that our rho value is less than our significance level, so I can actually choose which one I want to use. In terms of I've got my rho value, I've got my test statistic, I've got my, but I haven't got R value. Now because I haven't got the R value, that's why I'm going to be comparing. So let me just write that down. So as we don't have a R value, instead what we're going to do is we're going to compare the sig level to the P level. So, and again what I'm going to then do is just use a bit of mathematical proof for this. So again, it's the p-value is 0.0446, and that's less than the significance level, which as a decimal is 0.05. So what does that therefore mean? Well, it means then what I need to do is reject the HO and then the correlation exists between rainfall and temperature, which kind of makes sense because you would have think that rainfall will affect temperature, maybe not in the UK, but there you go, and that there is a formal link between the two, and that should be enough to get you the marks for this particular question. So let's have a look at our second example. So in our second example, it says that a jewellery auction house measures the masses and selling prices of a random sample of 10 pieces to see if there is any correlation between the two. The null hypothesis where HO is equal, where rho is equal to 0. The alternate hypothesis where rho is not equal to 0 with a 5% sig level. Explain why the hypothesis takes this form. And then B, the product moment correlation coefficient for the data is where R is equal to minus 0.148. The critical value for the test is plus or minus 0.6319. State with reason whether HO is accepted or rejected. So again, let's have a look at the first step. So first of all, let's answer part A. So let me just split this page up in terms of what A is talking about. So again, what we need to do is explain why the hypothesis takes this form where where rho is equal to 0 and there. Now the reason why it is because basically you want to sell if correlation exists. So to sell if a correlation exists. So all we're looking for is the fact that there is a link between the mass of a piece of jewellery and its selling price, because you think that well, in some cases it may not be true. It obviously depends on rarity, there's other factors that may come in, but you would expect in terms of gold, how heavy it is will also have an impact on its weight. And again, so in terms of correlation, you could find that again you just want to see if a relationship exists between the two, and that's the reason why. I personally would see this as a 1-mark question, so you don't want to think too much about it as long as you're writing something down. Now in terms of B, what we then need to do is go through the steps. So again, first we need to state what our hypotheses are. So here we've got that rho is equal to 0 and H1 is where rho is not equal to 0. We're looking at 5% sig level, and looking at the hypothesis, we're looking at a two-tail test. Now in this particular example, what we're going to be doing is we're going to be comparing the R value to the critical value. We're comparing R value to the critical value. Now, as I mentioned, it doesn't really matter which one you use, so in terms of comparing the critical value with the R value, or like we did previously with regards to the test statistic and the significance level, it's all based on what information is being given to you in the question, because obviously you're not physically calculating anything. It's all about reading the information that's given and choosing a method, an appropriate method. So in terms of this, what we've got is that our R, or our PMCC is what we tend to call it, is equal to minus 0.148, and our critical value is equal to plus minus of 0.6319. Although we've got two values, it's just like our boundaries to see where our R value exists and how, in terms of comparisons, which one is close to 0. So in terms of my conclusion, so let's just write this, in terms of the actual conclusion, what we state is that as R is closer to 0, then the critical value there is insufficient evidence at 5% sig level to reject HO. So in other words, what we're doing is we are accepting HO. And what that means is that there is no correlation between mass and which, again, even though I did say that you would expect it, but again, you can't really judge it because it depends on how old and how rare a piece of jewellery is, and it's all about personal choice as well. So that would be good enough for your marks for that particular question. So let's have a look at our third example. So in our third example, it says that the number of caffeinated drinks a person consumes during the day and the number of hours sleep they get at night that night are suspected to have a negative correlation. A random sample of 30 people was surveyed to investigate whether any correlation is present. The hypothesis HO where rho is equal to 0 and an alternate hypothesis where rho is less than 0 are being considered at a 10% sig level. The critical value for the test is where R is less than 0.2826, and the PMCC for the sample is where R is equal to minus 8.37. State with reason whether HO is accepted or rejected. So again, let's first of all set the parameters of this particular question. So we've got HO is where rho is equal to 0, and H1 where rho is less than 0. We're looking at a 10% sig level, and it's a one-tailed. So in terms of this information that I've been given, I know well that R equals minus 0.837, and I also know that I've got a critical value of minus 0.826. So in terms of the general conclusion, what does this mean? Well, it means that as R is further away from 0 than the critical value, sufficient evidence to reject HO. So in other words, what we're doing is we are accepting H1, and then all we need to say is that there is, and this is where the real life meaning, so there is a negative correlation between amount drunk and the number sleep. Now again, I strongly recommend that if you've got access to a textbook, have a look at practicing these questions. Sometimes it's just getting used, personally speaking, it's all about getting used to how the questions are written. As you can see, we've gone nowhere near a calculator, and again, these questions won't carry that many marks, but again, you can't take that risk when it comes to exams. You try and maximize your marks. So it's about picking the information, being able to choose which one you're comparing, and then going for biting the bullet and picking a conclusion with the 3 steps in terms of mathematical statement, mathematical evidence, and the real life meaning in terms of the context of the question.